So now let's talk about the phenomena of beats. Now, in practically, you will often hear in music beats are given. Beats are given. Now, this beats is nothing but if you want to understand this, you can term beats to be the phenomena which arises from interference of two or more waves. These are known as beats. Now, say suppose this is a wave, this is another wave, this is your third wave, this is fourth wave. Now, due to this interference, you will hear a different sound. That is, even though individually you are hearing the sound, but still after the interference, you will hear a different sound. Now, this particular effect is known as beats. So you can see that when two harmonic sound waves which are very close in frequency. Now, as we have discussed in our harmonic oscillations, harmonic waves are those waves which has very small displacement. This has very small displacement are harmonic waves and which travel to and fro. So this is what we know as harmonic waves. Now, when two harmonic waves of very close frequency, now the frequency, say suppose this is omega 1, the frequency, and this is omega 2. Let this two be the two frequencies. Now these two should be close. But they should not be equal. But omega 1 and omega 2 should not be equal. This is the condition for the occurrence of beat, not be equal. So let's see what happens then. So now we have mentioned sound waves of close frequency, whereas they are not equal, are heard at the same time when they are overlapped. When you are playing a music of almost same frequency and these two sound waves overlap, then what happens is we hear a sound of similar frequency. We hear a new sound of similar frequency. Okay, similar frequency. Now I'm just explaining to you the physical aspect of beats. That is, this new frequency that we hear is actually, you can term this as the average of the individual frequencies. The average of the individual frequencies. This is the new frequency that we heard. But also we hear something else also. That is, even though we hear a different sound, but also we hear a type of different sound also. We hear audibly distinct waxing and waning of the intensity of the sound. That is waxing and waning. I've used the term waxing and waning. Now, waxing and waning means the increase. We have used the term waxing and waning. Waxing and waning. So, this means increase and decrease in the strength of the sound, or you can say of the intensity of sound. So this is what actually occurs. Now when you're playing two music of the same frequency but they're very close, not almost the same frequency but close frequencies, you will hear a third sound and you will also feel the increasing in the strength and decreasing in the strength of that sound. So this particular phenomena is known as beats. Now you can easily see that this particular phenomena is used by artists while they're playing some song. So this beat sometimes is used to create new sounds. And sometimes what the other musicians do is they keep on tuning the sound. Now you can see that before starting a concert, people tune the instruments. Now why do they tune the instruments? So that they can match their frequency. That is, frequency 1 equals to frequency 2. They can match the frequency. If they can match the frequency, that means beat, that's the phenomena of beats won't occur. So that is the reason why before a concert some musicians tune the instruments so that they can reduce the effect of beats. But sometimes, especially during the playing of DJs, you will see that they purposely create beats, purposely interlap or overlap two sound waves that are very close to each other to create a new sound. So in this way, we can understand the physical aspect of beats. Now let's go to the mathematical part of beats. So let us consider one sound wave to be S1 equals to A cos of omega 1 t. The other one, let it be A cos of omega 2 into t. Now we know we had this particular equation. Now from this equation, how did we come to this equation, you may ask. So what we did was, now since it does not matter whether you take sine or cos because both are sinusoidal function, this is sine or cos, you can easily interchange or you can easily define one wave into the other. So now we have taken these two waves at the same position, at the same position, that is at x equals to 0. So the wave can be expressed as S1 equals to, this kx term gets cancelled, that is it becomes 0. So we can write this as A cos omega 1 t into A2 cos omega t. So this is how we can express this. So if we apply the principle of superposition, since these two waves are overlapping one onto the other, so by superposition principle, now please keep in mind we have discussed what is superposition. Superposition principle means that when two waves overlap one after the other, the resultant wave is the algebraic sum of the displacement of the individual waves. So according to superposition principle, we have S resultant is actually equal to S1 plus S2, which is equal to A, I am taking A common out, A cos omega 1 t plus cos omega 2 t. Cos omega 2 t. So this is what we have arrived. Now we will be using the trigonometric idea of cos A plus cos B, which can also be written as, now please keep in mind, be very sure regarding the trigonometric identities. So this can be written as 2 cos of A minus B by 2 plus, this is whole into cos A plus B by 2. I am writing this over here in a proper way. 2 cos A minus B by 2 into cos A plus B by 2. So this is a way of writing. This is a way of writing. We are converting cos A plus cos B over here. So if we relate this to, our resultant becomes, if this is cos A and this is B, if this is A and this is B, so my resultant equation becomes twice A cos of omega 1 minus omega 2 by 2 into cos of omega 1 plus omega 2 by 2 into t. So this is what I come to. Now this can be further written as, this can be further simplified to S is equal to, now from over here this particular expression this particular expression, I'm writing this over here. This is omega 1 minus omega 2 divided by 2 into t into omega 1 plus omega 2 by 2 into t. So again, using a trigonometric identity, what I can do is, I can do this twice a cos of omega b into t into cos of omega a into t. Now what is omega b and omega a? Omega b is actually equal to omega 1 minus omega 2, omega 1 minus omega 2 divided by 2, and omega a is actually equal to omega 1 plus omega 2 divided by 2. So I'm doing a substitution. Now there are different conditions that will arise. That is, now what happens when omega 1 minus omega 2 is very less than omega 1. Say suppose this is very less than omega 1. This implies omega a is greater than omega b. So if this and this is very less than omega 1, the difference between these two, if these two are very small, this is the difference between these two are very small, so this will tend to 0. Since because of the production of beat, I have taken omega 1 and omega 2 to be very close. So we may have this particular condition where then omega a will be very much greater than omega b. What was omega a? Omega 1 plus omega 2 divided by 2. What was omega b? The difference divided by 2. So the resultant wave is oscillating with the average angular frequency of omega a. Now if this tends to 0, this two quantity tends to 0, then we know, please look over here, this point, please look over this point, cos 0 degree is actually equal to 1 or tends to 1. Because if this quantity is very small, then it will tend to 0 and this will tend to 1. So the overall wave, the overall frequency of the wave, is given by omega a. This is what you will get, that is the overall frequency will be given by omega a. However, the frequency may be same, but the overall, that is the overall amplitude with respect to time is not same. So this is what we get. So now the resultant intensity. Now intensity depends upon your amplitude. Let's have a look. Intensity depends upon amplitude and not the frequency. Okay. So the intensity of the resulting wave therefore the intensity will go up and down, and it will, that is the resultant waxes and waning of the particular resultant wave will increase and decrease, that is intensity will increase and decrease. Now the displacement, that is the displacement of the wave will increase and decrease with the relation of their frequency, Now the amplitude will change with the change in frequency, that is the displacement will change with the displacement in frequency. So we can say that the wanes and waxes of the particular wave, that is the particular resultant will depend upon the angular frequency, which is 2Wb, which is equal to W1 minus W2. This is actually equal to 2b is equal to W1 minus W2. Now, since the term cos b by t, is the resultant, that is the resultant or is the main factor for causing the up and down of the intensity. This is your twice a cos omega b by t and cos omega a by t. So this is the amplitude. So amplitude does not depend upon this frequency, but amplitude will depend upon this particular term. So this term, if this tends to 0, this will be equal to 1. So what we know is that 2wb, this is 2wb will be equal to W1 minus W2. W1 minus W2. Now, what is WB? WB in our initial condition was W1 minus W2 divided by T, and this is what is given in your book. Now, students often get confused with the terms. So, the derivation is actually this. W2WB is equal to W1 minus W2. So, the resultant intensity will depend upon this. Now, therefore, since we know the frequency of the angular frequency is given by twice pi by t. This we have already discussed. Angular frequency is given by twice pi by t. So we know omega is equal to nothing but twice pi by nu. That is, this is the frequency. Opposite of time t is your frequency. This is the angular frequency. Now please keep in mind, this is the angular frequency and this is just the frequency. Okay, so now the beat frequency. Now if we talk about the beat frequency, what will be your beat frequency? At what frequency will the beat come into play? So that particular frequency, let this be named as frequency is equal to beat. Now let's have a discussion about beat frequency.